So here are some basic steps for dealing with algebraic limits. The first thing is very important. We actually need to substitute the x into the expression. Okay, without substituting the x into the expression, we don't know if we can evaluate it or not. So when we substitute x in the x equals a into the expression, if we get an indeterminate result like 0 over 0 or infinity over infinity, then we can apply the limit. We can do some rearrangements and try to figure out the limit. So one of the rearrangements that we can do is we can do like an argument. Okay, so in this case here, we can say that as x gets large, and this is for limits to infinity, as x gets large, we can say that these terms are insignificant compared to the really big number squared terms. So if that's the case, we end up, this graph starts behaving like 2x squared over x squared. Well, that simplifies to just 2. So that's one way of doing it. That's kind of how the examples the way we did in our examples. Number 2 here, I actually didn't show in any examples, but this is just as valid. This is a bit more work. It achieves the same thing, but this is a more algebraic process. So what we can do is we can actually get rid of the powers by dividing every single term by the same power. Okay, and so what ends up happening is we end up this 2x squared over x squared cancels. Same with x, we end up with 2 and 1. The rest of this, we can say that as x goes to infinity, this is going to end up being, because we have a higher power in the denominator, this tends to 0. Same with this one here, that's going to go to 0, that's going to go to 0. So we end up with the ratio of 2. So that's another way we could do it. Okay, and it's essentially kind of similar idea to here, except here we didn't do all the kind of algebra canceling out. We just used an argument. The other one is using, and this is only again good for limits to infinity, we can use the relative power of functions. So the more powerful the function, the more it will outgrow. And this is very useful when we have expressions that are mixed with, polynomials and other things, because we can't algebraically rearrange those very easily. Okay, so if we can use a relative power of functions, that's very useful. This one here, I'm just going to put a star next to it because this is very useful. But be careful, and I'm just going to highlight this as well, because this is only good for endpoint behavior. Okay, not for local behavior. We are going to have to develop some more strategies to deal with those local behaviors, and one of them was things like this. We use established limits. Okay, so for example, sine x over x. And there are other established limits that help us out with local behavior, because we aren't able to use that strong over weak argument when we have these local behavior ones. Okay, so these are just the basic steps. This is kind of the start of how to deal with algebraic limits. Okay, and we're going to do some harder ones as we go through this course.